Hi, in this video we will talk about WCF. WCF is Windows Communication Foundation, which is a framework introduced by Microsoft into .NET framework. And they gave this framework, WCF framework, from version 3 and onward. We will talk about WCF in framework 4. Using WCF, we can build our services which we can expose on different channels using different bindings like over HTTP, TCP, IP, or if both server and client are on the local machine, we can use netNamedPipeBinding, which is very efficient to communicate over the same machine. After building the basic service, we will see how we can host our service. There are many options to host WCF services. We can host a WCF service in a console application, in a Windows application, and we can host it in IIS as well. And in fact, with IIS 7 and Windows Server 2008, Microsoft has given Windows Activation Client WAS. And using WAS, we can host services that can be exposed on multiple bindings in the IIS as well. Up to IIS 6, we could only host services which are exposed on a basic HTTP binding or wsHttpBinding binding. But with the new IIS 7 and the concept of WAS, we can expose WCF services on multiple bindings over in the IIS as well. But in this video we will cover only the WCF host, which is part of the Visual Studio, and we will host a service in Windows service. And at the end we will see also how can we use WCF Test Client to test our services. WCF Test Client is a kind of basic generic client that we can open our services and see the methods that the service has and send the invocation commands to those methods. And we will also build a custom client to a already published service. So let's start with Visual Studio, new project, and from WCF templates, WCF service library, and over here we can give our say print data service. So using this template, Visual Studio will build us a service that already has the basic infrastructure in it. We can see these two files, an interface, a class, and a configuration file. When we talk about WCF services, there is a concept called ABC. So we need to understand what is the concept of ABC. A stands for addressing, B stands for binding, and C stands for contract. A, address means where this service is available. So there should be a unique URI where the service is available, and using this URI we can send our messages, SOAP messages, at that address, and those SOAP messages or SOAP envelopes will be used by the service, and based on the SOAP a message, some method will be invoked and a result will be obtained and a response message will be sent to the client. So address tells us where this service is hosted or available. Then binding, B stands for binding. Binding means which channel the service is hosted on. Is it available on HTTP, HTTPS, netTCP, netnamed pipes, or if in case of asynchronous communication, is it using some MSMQ? We have a number of options available in .NET framework, like for the very basic services, like we had ASP.NET services called ASMX services, we have the option to use the basic HTTP binding. If we want to use a bit advanced options, we can use WCF star standards. We want to use WS star standards, we have the wsHttpBinding binding. And if we want to have dual communication, duplex channel over the HTTP, we can use wsHttpDual binding. Similarly, on netTCP, if we want to expose our service over the same network, intranet, we can expose our service over the netTCP binding. NetTCP binding is much faster if we know that the service and the client are both on the same network or on the intranet. Then we should prefer to use netTCP binding instead of any HTTP binding, because netTCP binding is much more fast, and also we can make use of some of the features like Windows authentication and authorization. Similarly, like we have dual HTTP binding, we have dual netTCP binding as well. If both service and client want to establish a duplex channel with each other. And there is another binding which is netNamedPipeBinding. That is best if both service and client are on the same machine. So if both service and client are on the same machine, then we should prefer to use netNamedPipeBinding, because netNamedPipeBinding is even faster than the netTCP binding. But that works only if both client and service are on the same machine. If we are not sure, if the client which need to communicate to a service is not sure, like the service is available all the time, but the client want to send a message even if the service is not available at a certain time, and then we have the option to use the MSM queue. So in that case, client can send the SOAP message or the WCF request to any queue, and service can read from the message from the queue and then can do certain actions. So this is kind of asynchronous communication over the WCF framework. There is a built-in binding as well for MSM queue. We can use that. So for that, both service and client works on a queue, and the communication is based on the queue. When we make a service using the selected template that we used, so what does the Visual Studio does? It makes us an interface and a class. Now we have talked about ABC, and A stands for address, B stands for binding, and what is the third option? C. C is this interface, contract. That means what the service has to offer to its clients, what methods or what interface it is publishing or is available to invoke. So contract of the service tells us how many methods we have for the invocation, what are the parameters, what are the return types. So in here, in this project, this template has already made us this interface. This interface is iService1. It has two methods, get data and get data using data contract. Now to make these methods and interfaces available over the WCF, we have to add some attributes. For example, we have to add service contract attribute on the interface which we want to expose over the WCF. If I comment this attribute, this interface won't be available over the WCF. And similarly for the, we can have as many methods in an interface as we want, but the methods that we want to be available over the WCF, we have to decorate them with this attribute which is operation contract. So the methods within an interface, within the interface that has these attributes, will be available over the WCF. The methods that don't have this attribute won't be available over the WCF. And similarly, if we have some complex type which we want to communicate across, for example, in this method, this is operation contract and get data using data contract. We have to pass this composite type, complex type, and this composite type has to be defined somewhere, and we need to put attributes like data contract and data members on this composite type as well, so that when the method is invoked, these options like data contract and data member, Visual Studio.NET knows like which members it need to serialize when the package or the message is sent across. Okay, so the last option C stands for the contract. So that means when we develop a service, we need to have an interface, should be decorated with this attribute, and the interface should have some methods that we want to expose, and they should be decorated with the operation contract. And if there is a basic type that is being passed or returned, we don't need to do anything. But if there is a composite or complex type used as a parameter as a return type, then we need to define that return type and put data contract over the type and data member over all of its properties that will be sent across. Okay, and here stands the implementation. So there is a class that implements this interface. This interface is available over the WCF or will be available over the WCF, and these are the two implementations. So in get data, it simply formats strings, and whatever the integer value is passed, it say you enter this value and return this string. And in the get data using contract, client passes this composite type and it checks if this value is null. It throws an exception, and if there is some value, it just adds something to the existing value and return the same parameter. Okay, so we have seen the contract, and now we will see where is A and B. Okay, for A and B we have to go to the config file. A and B can be configured anytime. For C, like contract and its implementation, we need to write the code, and that code is once written is final. But A and B, like address and binding, we can change anytime. We can finalize our contract and its implementation. We can deploy our service, and after the deployment, we can go to its config file and can change its A and B. We can set any address and we can set any binding. In fact, we can make the same service available on more than one binding at the same time. And where we can specify those details into the app.config. There is another option. If you don't want to use the config file, we can use the declarative programming as well, but that is where we are hosting the service. If we are hosting the service through some of the application or Windows application, and if we don't want to use the config file to configure A and B, address and binding, we can write some code, and then we can host the service based on that address and binding through our own WCF host. But in this video we will only talk about the configuration options. Okay, in the configuration file we have this node system.web, and this node is system.service model is related to the WCF, and in here we have this services and behaviors. Okay, within the services we can write all the services that are available for that are available for the hosting, and within the service node we have to write the name of the service. This name of the service is exactly what is the implementation of the service. So it should be this namespace plus the name of the class. So this comes here, name of the service, and then in the host we can mention the base address. So this is the address where this service will be available. For example, I say this service is available on localhost port 8080, and instead of this wizard generated address I can say gnd services and print data service. So say this is my base address. I can specify a base address. The advantage of having the base address is like I can specify one base address like localhost port 8080 and GND services, and then all the interfaces that I'm exposing over the WCF can have their own address. So they will all use the base address, and then if I add something here, say interface name, so it will become a unique address for all the interfaces or for all the contracts that are available. Okay, and if I want to expose more than one base addresses, like one for HTTP and one for netTcp, net.tcp localhost, and then I need to give a different port, say 1990 GND services. So now I have specified two different kind of base addresses, one for HTTP and one for net.tcp. Okay, and now I come to the endpoint. Okay, endpoint is where I specify the binding and the contract, or in other words, all the ABCs are specified in the endpoint. So A is address, this is the address. If I don't specify any address, it will use the base address. If I don't have the base address, then I can specify all complete address from here, like HTTP localhost 8080 GND services, and then print data service over here. So I can give the complete address, or I can give like something print data service. So what will happen is the system will use this base address and concatenate this print data service at the end of it, and then it will form up the complete address. And over here I can specify binding. At the moment wsHttpBinding is specified, and this is the contract. Contract is, as I said, is the interface which we expose on WCF. Okay, I can, as I said, I can expose my service on more than one bindings. So what I can do, for example, if I want to expose my service over HTTP and netTcp at the same time, I just need to add another endpoint here. So I will say endpoint address print data service, and binding I will say netTcpBinding. So it will use the built-in netTcpBinding, and I am exposing the same contract over the netTcpBinding as well. If I have another contract, I can change the contract here, and that in that case I will be exposing one contract over the wsHttpBinding and another contract over the netTcpBinding. But in here, as I said, we want to expose the same contract, same service over more than one binding. So the clients that want to communicate remotely use this binding, WCF HttpBinding, and the clients which are on the same intranet, local network, Windows network, they will invoke the service over the netTcp. Obviously on intranet the calls will be faster, and we don't want to force our intranet clients to go over wsHttpBinding and make them perform slow. So we will offer, we will publish the service on both wsHttpBinding and netTcpBinding. This is the third endpoint. Third endpoint is MEX, and using MEX HttpBinding, and this is to change the metadata exchange. Metadata exchange is obviously when some client want to know what the service does, it need to know the metadata address, where is the metadata published for this service, and metadata is a WSDL document, WSTL document, which is XML based document, and through WSDL the client or anyone who want to know what the service does can go and see all the methods, the parameters, the details that this service is offering. So if we put this endpoint, then the service will expose the endpoint metadata exchange, and the clients can see the WSDL documents and know what this service does. If we don't put this line, comment this line, then the service will not expose metadata exchange. And usually when we take our service to the production, we comment this line, because at that moment, if we don't want to publish our web service, we don't want to publish our metadata for the service, then we can comment this line. Okay, so now with this configuration, I have my service available over localhost 8080 port 8080 for HTTP, and for netTcp it's over 1990 localhost. And to expose it on more than one binding, I have put more than one endpoints, and each endpoint I have to specify A, B, and C. A is for address, and B is for binding, and C is for contract. So for both of them my contract is same, binding is different. wsHttp and netTCP, and again address is also different. For wsHttp, it will use http localhost 8080 GND services and concatenate print data service at the end, and over here it will use netTCP localhost port 9090 and concatenate this print data service at the end. Okay, so our service is complete, configuration is complete, implementation is complete. We are using the default implementation that Wizard has given us, like one interface and its implementation with two methods, and for testing purposes we can use the same. No, we need to run this service, or in other words, we need to host or publish this service and then try to invoke some of its methods. So I will press F5 and see what happens. Okay, when I press F5, Microsoft Visual Studio, it has a built-in WCF service host. So when it detects automatically if there is a WCF project in your solution, it tries to automatically host that service when we try to debug the projects. So, and it tries to host all the WCF services within that solution using its own WCF service host. Okay, it tried to host our service, but there is an error. It says HTTP could not register URL HTTP plus 8080 GND services as port 8080 is being used by another application. So we need to make sure when we host our service on a certain address, that address and the port should be available. So that means on my machine port 8080 is already used by another process, so either I stop that other process which is using the port, or I change my configuration. So it's easy for me to change my configuration. I can say 8085 and then I can say debug. Okay, now we see this is our WCF service host, which is built into Visual Studio, and we can see our service print data service.service1. This is our contract, status is started, and its metadata address is this. So this metadata address we can use to see the metadata or the details of the service or the methods or the interfaces that this service is publishing. Now this second thing, this window, first of all, when we press F5, Visual Studio try to host this service, and if the hosting is successful, which in this case is, after the successful hosting, Visual Studio launches the WCF Test Client. This test client is also part of Visual Studio, and if the service hosting is successful, it takes the metadata address, this HTTP localhost 8085 GND services and MAX, and using this metadata exchange address, it loads the WSDL, parses the WSDL, and after parsing the WSDL document, it then lists everything, all the methods over here. So in this case, it says over this metadata exchange address, there are two services on different bindings. So one service is actually, the contract is same, iService1, but it is available in two different bindings. So iService1 is available on wsHttpBinding, and then same iService1 is available on netTcpBinding as well. If I add another binding, it will show another node as well. Now in iService1 over wsHttpBinding, these are the methods that are available. So I can select a method and I can say invoke. So it will now prepare the SOAP message, send it to the address, and that address it knows from this max WSDL, like which address to send this address to the message, and it has invoked the service. So say I specify this parameter 23 and it returned you entered 23, and that is what this method actually does. Whatever we pass the input parameter, it just formats say you entered the value 23. Okay, similarly we can expose our we can expose our service on as many bindings as we want, and we can test using the WCF Test Client. So it's quite easy and handy to test our WCF services. using Visual Studio. We don't really need to do a formal hosting, like if we want to intend our service in production to be hosted in Windows service or in IIS, we do not really need to do it at the early stage. In the beginning, we can start writing our contracts, methods, and for testing purposes, we just press F5. The service is hosted into WCF service host, and test client is launched, and we can test our methods using the WCF test client, which is quite handy and it saves time. And if we follow another approach, like we build the service and then we deploy it into IIS, and then through IIS we try to test it and launch it, it will take time, and also debugging won't be easy. In this case, debugging is quite easy. For example, if I want to debug this method, I can put a breakpoint, and from my test client, if I launch this, I get the breakpoint, and I can see the value 23 is passed, and it is formatting and sending that value back to the client. So launching, hosting, testing through WCF service host and WCF test client is very easy. It's just pressing F5 and everything is there for you. It saves a lot of time, and we should prefer to use, during our development, we should prefer to use these options, unless there is some exceptional case and we have to use some other option. Okay, I just want to show you one more thing in here. If we want to host our service or test our service or debug our service using another option, and we don't want Visual Studio to automatically host this service using the default WCF host, and we don't want to launch the WCF test client. So the project which are WCF project, there is, if we go to its properties, like right click, go to its properties, we'll get this window, and in here we have this WCF option tab. So this is the option. We can say start WCF service host when debugging another project in the same solution. So if we have this option checked, Visual Studio, whenever we debug any of the project in this solution, if at the moment we have only one project, if we have another 2-3 projects, any project we debug, it will automatically launch this service, WCF service, for if this checkbox is checked. And this is handy, like if we have a client over here for the same service and we want to debug the client, we debug the client, Visual Studio will automatically detect, oh, this is a WCF service project, it will, based on these settings, it will automatically launch it. But if we are hosting this service somewhere else and we don't want Visual Studio to launch the host and the client, we can uncheck this box. Okay, in this case Visual Studio won't launch the host. It will try to launch the WCF test client, but it won't launch the host. Okay, and the next option we will see is how to host. Okay, we have seen this option, like WCF, using the WCF host, and now we will try to host our service into the Windows service, and that is quite easy. We can host our WCF service into a console application or into a Windows service type of project. So we say add new project to this solution, and we go to this Windows, and we need to select Windows service and we can say print data service host. Okay, it should go in here. Now this is a Windows service project, and when we create a Windows service project, Visual Studio, what it does, it creates this service, and if we go to its code, it automatically gives us on start and on stop. This on start and on stop methods are called when the service is started, on start method is called, and when the service is stopped, on stop method is call. Okay, so to host a WCF service, first of all we need to add a reference, and that reference is system.service_model. System.service_model namespace contains all the classes that are provided by the .NET framework for the WCF options. Okay, so we need to add system.service_model namespace so that we can use WCF framework classes, and one of the class which is called service host, which is available in system.service_model namespace, will be used to host the WCF service. Okay, if we are using Visual Studio 2011 and .NET framework is 4, then when we create a service Windows service project, the default target framework is .NET framework 4 client profile, and we can keep it same. In fact, yes, we don't really need to change it. We will see if there is some conflict, then we will try to change it. Okay, so now we have added service model namespace, and we can go to our service code, and what we need here is to declare service host, and service host is using system.service_model. So service host, and in here I can put a try catch, and I can initialize my service host, and when I initialize my service host object, I need to pass what is the type of the service that I'm hosting. Okay, now the service type is here in this project, print data service, and that is service 1. Okay, now to refer the service 1 into this project, I need to add a reference, and that will be project reference. So I will add this reference here, and I can now use print data service dot service 1. So this is the type of the service that I'm going to host into service host. So I have initialized my service host object, and during the initialization I have passed which service I'm going to host, and then after initialization I can call the open method. So open method, it will launch this WCF service over all the bindings that are available into the app.config. Okay, the other thing we need to note here is, because the service host is into this project, so whatever the configuration we need to apply to this service, that configuration should be available into this app.config as well. If that is not available, it won't have anything, because it won't go to this DLL. This project is compiled as a DLL, so this host won't go to the configuration file of this DLL. It need to have all the configuration into its own. So what we will do, we will simply copy this system.service_model node and bring in here. Under the configuration node. Okay, that's it. And if we do some change here and we want to apply that change into this app config as well, then we need to do at the both of the places. Okay, so now on the on start we have started. Okay, what we can do, string error message if we want to see, and okay, error starting service, and what is the error, we can format the message ex.message, and we can use event log dot write entry, and in here we can pass our print data service host and the message, which is error message, and then we can type what kind of error it is. We can say this is an error, warning or whatever, and we can throw the same exception. Okay, so in this, if the service for some reason fails to start, at least we can go to event log and can see what is the error. And if we want to see the detailed error, then maybe it would be good to add instead of error message, we can say exception dot to string. So in this case, it will show us all the stack trace and all the details, what happened to the service, why it failed. And on stop, we need to put a try catch again, and we can say service host dot close. So this will unpublish the service from its channel, and in case of an error, we can again write an entry into the event log. So you can say error stopping the service. Okay, that's it. Now our service is launched. When the service will be started, the onStart method will be invoked, and as a result of this method, service host object will be initialized with this service, and the open method will be called. Once open method is successful, the service is launched, is available on the bindings which are mentioned in here into the config file. And on the service on stop method, the service host will be closed and all the channels will be closed. So service will be unavailable after the service is stopped. Okay, then when we install the service, we need to add the Windows service installer as well. That we can right click over here and can add the installers, and we can give the service names. So this will be the display name. We can say print data service, and same thing we can mention here, print data service. So when we will install this service, the service will be available with this name. Okay, now another thing, because this is a Windows service project, we have to launch this service, we have to install this service, and because this is a Windows service, so we have to run the setup or use the command line exe that register this service into the services list, and then we need to start the service. Okay, if we don't want, during debugging we want to do a quick thing, so we don't really want to install the service and then start the service. So if we want to do like that, we can say if debug else, and we can say and if. Okay, so this is the code to launch the service. So service base, and then into the services, it builds up all the services, because we can, into one application, into one Windows service project, we can create more than one Windows services. So it creates services to run, an array of the services to run, and only add one service 1, and then it calls service base.run. So it will run all the services that are added to this array, and these are Windows services, not the WCF services. So when it will run this Windows service known as service 1, we will get this onStart method invoked, and over here we will host WCF service here actually. Okay, now we go back. In case of debug, we don't want actually to don't want to use the service base. We simply want this class. So you can say start in debug, and that's it. So when we go to this method, oops, I pressed. Okay, in here we can simply call on start method. So if we are in debug mode, now take some parameters, so we just pass the null. So if we are in debug mode, it will come here and it will call the start and debug method, and then start and debug method will invoke on start method, and on start method will create that service host object and open the channel and publish the service. Okay, and we don't want this process to finish or complete. If we don't stop at this line, we have to wait for some time at this line. If we don't wait, this process will complete and finish, and once it's finished, the service will also be will become unpublished. So we say system.threading.thread.sleep, and we can specify some time span here. If we know we just in debug mode we just want service to be available for 1 hour or few minutes, we can specify the time span here. And now the system, after launching the service in debug mode, will wait at this statement, and during that time we can launch, we can test or debug our services. Okay, so now we have this Windows service ready to host our WCF service. What I will do, I will simply put the breakpoint here, and I will say debug this project. Okay, I hit the breakpoint. Okay, go to this method. This method simply calls on start, and service host is initialized, and now it is trying to open the service host. Okay, so there is some exception. So let's see what is the exception. It could not register 8085. Another application is already registered. So that means this port is already in use. That means some of my existing, the previous host is already running, which is using. So I need to stop this process and see which one is running, and stop all the processes that are already using this port. Okay, so I just stopped everything, and okay, let's debug now. Go to this method and service host object initialized. Okay, now the open method is successful. That means the service has been hosted successfully, and we can see here into our service host, like it is using 2 base addresses. It has successfully run the configuration. So HTTP localhost 8085, GND services, and netTCP 9090. So it is using 2 base addresses, and the service is hosted. You can get some more detail above from this about your host. Okay, now the service is hosted and system is waiting at this line. Okay, now we know Visual Studio, because we unticked that option. This option, this WCF option is not ticked, so system did not launch any of its default host or test client, and we have hosted our service using this Windows service. Now our service is ready. If we want to see, to make sure if the service is ready or not, what we can do, we can use netstate command, and so /a, it will list me all the processes and the relevant ports to this a.txt on C drive. So I can go, and in here we can see where is 9090. So we yes, so we should see, so a TCP port 9090 is listening, so service is ready. And similarly 8085 should be there as well. 8085, yes. So you see some process is listening at 8085 and 9090. So service is available on both HTTP and TCP protocols as well. Okay, now we need to invoke or call the methods of this service. Okay, now Visual Studio did not launch the test client, but we can launch that test client ourselves. That test client should be available in Visual Studio tools. So if we go to Visual Studio command prompt and we write WCF Test Client, so this is the test client that Visual Studio automatically launches. If it doesn't launch, we can go through the command prompt and write WCF Test Client and launch this client. Now from here we can add a service. Okay, it already have the previous added services into this its own list. So our service is available at this localhost 8085 GND services and MAC address. This is the metadata exchange address. Okay, I say launch or contact to this service. It contacted the service on that metadata exchange address, got the WSTL document loaded, and has listed all the available bindings that it finds. So we see now our service is launched through a Windows service and is available on wsHttpBinding and netTcpBinding. And if I write something here, it should return me. Okay, we had a breakpoint, so it just hit the breakpoint, and yes, so service is working over here. And let's stop debugging. Okay, we have tested our Windows service in the debug mode. So because when we are in the debug mode here, this code is executed, which is just having an instance of this service1 class and invoking the start and debug mode. But this is not the real Windows service. It's only in the debug mode. The real Windows service is when we compile it into the release mode and install this service into the services list, and then we start the service. That is the real testing. So to do that, we have two options. One is to compile it into release mode and then use the install util command prompt and install the service. The other option is we create an installer project, and as part of the installer project we install the service. So we create the setup wizard, and that setup wizard, when it runs, it installs the service. Okay, so we will just use the install util.exe. I have compiled the service into release. Please make sure you compile the service into release mode. If you compile it into debug and try to register as a service, when you start the service, this method will be invoked. This code will be invoked, and that is not the service. That is just like a console application. So this code must execute when you run it into the real Windows service mode. Okay, so I have compiled it into release mode, and to install the service we have this install util, and install util is the command prompt available into the Visual Studio tools. And then we have to give the complete path of the Windows service. So in our case, it's from release folder print data service host.exe. So this is print data service host.exe, and I will just install util and the complete path of the exe, and it should try to install the service. Now, as part of the service installer, we specified, and in fact, if we look here, service installer, and if we go to the properties, say start type is manual, like the service will not be started automatically. This is the display name, and if you want to give some description, the description can go here. And account is user. So if we say install into local service or local network service or local system, it won't ask the user ID and password. But if we specify user, then it will ask, as part of installation, it will ask the username and password. So we can give a Windows username and password. Please make sure this will be the account that this WCF service will be hosted against. So if the client is trying to communicate to the service and has to pass the account name against the services, WCF services being executed or being launched, then this will be the account. So I specified my account details and it says transaction install has complete. So if we go to services list, we should find the service with its name. So print data service is there and it's in manual mode and its user is what we specified here, and it's not started. It's not started, that means there is no process onto this machine which is listening into port 8085 or 9090. We can confirm that. Control F, 8085. So 8085 doesn't exist, and so 9090 doesn't exist. So no process is listening at our specified ports. And now if I start the service, the onStart method should execute, and as part of the execution of the onStart method, the service host object should be instantiated with the type which is given, and then the service host open method should be called. That means the process, the Windows service process, this process should now be listening into the two ports for TCP 9090 and for again HTTP 8085. So we go and see if the service is hosted successfully. Control F, 8085. Yes, here it is. So LTGD is on this laptop. Okay, there is a process which is listening, and if we want to get more details, you can search netstat / the help, and you can see the options which, and you can find which process is listening and all the other details as well. Okay, so our service is hosted through Windows services, through this service. As long as this service is running, WCF service is available. If we stop this service, WCF service will not be available. Now again we will try to test it using our WCF Test Client, and I will go add service. Okay, again service is available, I can invoke the method. Now if I stop this service, print data, and I try to launch the test client again, it should fail. See, it did not find the service. Okay, so we have seen two ways to host our services. One is using the Visual Studio Host process, which is launched automatically for the WCF projects if that checkbox in the properties is checked. And if we don't want to use that default process, we can make a console application or a Windows application, and within any Windows application, a console, a form-based application or a service-based application, we only have to write the 2 lines of the code to host any WCF service, and that 2 line of the code is here. As we have seen, it's just instantiating the service host with the right type which implements the WCF interface, and then call the open method. Now these 2 lines you can invoke into a console application, you can invoke it into Windows form-based application or Windows service. So wherever you want to host your WCF, just write these 2 lines, instantiate the WCF host, service host, and then call the open method. And when you want to stop your WCF service, just invoke the service host.close method. And if it is Windows service, then we can install Windows service and we can start and stop from the services list here. Okay, now we will have a look at how can we make a custom client. How we have tested this service using the WCF Test Client, but if we want to make our own client, which is usually the case, so if there is a service, so there is some client, some application which is trying to execute the method of that service. So how can we do that? Okay, to make a client, what we will do, we will just make a Windows form-based application, and we will see how can we invoke methods of this WCF service from a Windows form-based application. So I said add new project, and from Windows form application, and here I can say print data client, and it should go into this folder. Okay, so we get a form, and over here okay, from tools, let's just put a button, and at the back of the button we okay. Now from any application we have two options to invoke the service. One is we add the reference of the service, and to add the reference of the service we can go and say add service reference. Here if our service is running, in this case it's stopped, so if we add the reference, give the address of the service, and we add the reference here, it will automatically discover all the methods and create a proxy class and add that proxy class here. And what we need to do is when we want to invoke the method, we say service1, which is the proxy, or service1 proxy or client, whatever class it's generate, and then it's proxy object, initialize it, and then call proxy object dot its method, whichever method you want to use. In that case, this proxy class will be generated by the framework when we add the service reference. But if we don't want to do that, there is another way, and that is we can do it programmatically, and for that we need to again add a reference, and a reference to system.service_model. System.service_model. Okay, now wsHttpBinding it should be S capital wsHttpBinding, also yes. So using service model we create an object of wsHttpBinding. We initialize this object. This is the class given by the framework. Right, next we have another class endpoint address, and we initialize our endpoint address, and we can give the URI, our endpoint address URI. In our case, endpoint address we can get from the config file, and that config file exists in both service and the host projects. So if we want to use wsHttpBinding, we have to get the HTTP address, and we know the complete address will be this one, concatenation of the base address plus the address specified in the endpoint. So this is the complete address of the service on wsHttpBinding. Okay, then we have a channel factory class. Okay, channel factory is okay, yes. Now we need to specify the interface as well. It is a generic class. Channel factory is a generic class. We need to specify the interface. Now usually the interfaces which are shared between services and clients, they should they should be in a common folder, and that common folder should be referred by the service and the clients as well. But in our case, we don't have the interface into a common project, so it only exists into this service project. What we do, we add a reference to the service project, which is not a good practice, but it's just for testing purposes. If we want to do a standard good practice, then we need to take out the interfaces or all the common definitions that need to be accessed by the server and the client side, and they should come into a common project, and that common project we can refer from the service and the client as well. So but for testing, I will only add this reference I service1, I think. What is our interface? Just let's verify what is the, yeah, it's I service1. Okay, yes, using print data service. Okay, so now this is the interface. We created a channel factory, and then from channel factory we can say create channel, and then this create channel will return us I service1 interface object. Okay, so I service1, and that is, I can say, proxy object, and I can call my methods on this proxy object dot get data. So I can pass a value, say 45, and I should get a string return value from the service. Right. Okay, now let's run this code and see what do we get. Click the button, and at the back we come here. We created the object for binding, endpoint address, channel factory, and create channel object will create the channel. Okay, so endpoint must have a valid address specified. So if address is not valid, is our service not running? No, the service is running. Okay, what went wrong? Something went wrong. Our service is running, and we have this wsHttpBinding address is correct because we copied and it's concatenated. That's fine. Channel factory. Okay, yes. Okay, so we need to give this yeah, we need to pass our binding and the endpoint address to the channel factory. Otherwise, channel factory won't be able to create the channel. So our endpoint binding is wsHttpBinding, and endpoint address is endpoint address. So now based on this address and binding, the channel factory will create the object. So because they were missing, that's why we had, oops, I just pressed F5, and service1 is the active project, so I create this as startup project and then press F5. So F10. Okay, so now the channel, okay, now this transparent proxy object is generated, and now the method is invoked on print data service. Okay, fine. So we had that debug point set into our service. Okay, for some reason it is going to debug the service as well. So, I need to check why this is happening. Maybe some configuration issue. So, but if we, yeah, it's only first time, and second time it is fine. So now it has invoked the service, and we can see the result of the method call. And shift F5. No, if this is This is using the wsHttpBinding. Now say if we want to use netTcpBinding, we simply have to declare netTcpBinding. Please also note, like I'm using everything standard for all these bindings. If you want to set some timeouts, another configuration, you can set it here, netTcpBinding, that all these close timeout and all these things, you can check these attributes. And in that case, if you want to use netTcpBinding, our address will become here net.tcp localhost and 9090, and over here we will just give netTcpBinding and the same address point, and now the client can invoke the same method over the netTcpBinding, which will be faster than wsHttpBinding. And if we are using netNamedPipeBinding, we need to change the address here and the binding here as well. Okay, this is if we want to use through the code. If you don't want to create the proxy, why we should use this option when the proxy is like you add a web reference to a client here, and the wizard goes to the WSDL, read the WSDL, generates a proxy and everything. We don't need to write any code. The only thing we need to do is we instantiate the proxy object and call the method, which looks much easier. But while we are developing, what happens is usually the service interfaces keeps changing. Some new method is added, parameter is changed, anything. So in that case, what will happen is any change in the contract, we will have to update the service reference. So if you have added a service reference, you go to that reference and update that reference. So either you do that. Yes, in that case, either we update the reference every time we make a change in the contract, and if we don't want to do that, we want to avoid that, then this approach is better. In this case, what we need to do is we need to keep the interface iService reference or whatever the interface is into a common project. That common project will be referred by the service and the client, and any change in the interface should be done in that common project. And by just recompiling service and the client, everything, both of the sides will be aware of the change, and we don't need to update any reference in anything. So